Hello again. In the previous lesson, we practiced graphing quadratic functions using the vertex, axis of symmetry, intercepts, and symmetric points. In this lesson, we're going to solve quadratic equations. We will use things like factoring, things like the square root method, things like the quadratic formula, and something called the discriminant. So let's begin with the quick rules. First of all, we're going to solve by factoring when the quadratic factors easily. Okay, that's very important. We're also going to use the quadratic formula for any equation. If you recall, the quadratic formula is here: ax squared plus bx plus c equals 0. And then the quadratic formula can be written also as x equals negative b plus or minus the square root of the discriminant, b squared minus 4 times a times c, divided by 2a. Okay, so this is the quadratic formula. It's like a cookie cutter formula. If you know all of these, all you do is plug it in and solve it. It's really that simple. And then this is the discriminant. The discriminant tells the number and the type of real solutions. Okay, so let's go ahead and begin so that we can see how this applies in terms of algebra. So this question says solve x squared minus 7x plus 12 equals 0. State the solutions and check one solution. So this quadratic factors very easily. Okay, we need two numbers that multiply to 12 and add to negative 7. Okay, so multiply to 12 and add to negative 7. Okay, that's what we need. So this problem here, x squared minus 7x plus 12 equals 0, will factor very easily. X minus 3 and x minus 4 equals 0. Now, using the zero product property, if two factors multiply to 0, then at least one factor must equal 0. So in other words, we set these equal to 0. X minus 3 equals 0. X minus 4 equals 0. Add 4 to both sides. It's going to be x is equal to 4. Add 3. X is equal to 3. Okay, so these are our solutions. Now, let's check one of the solutions. So let's check 3, for example. So when we substitute 3 into the equation, we have x squared minus 7x plus 12. And we're going to substitute 3 in there. 3 squared minus 7 times 3 plus 12. This is 9. 9 minus 21 plus 12, right? 9 minus 21 plus 12 is going to equal 0. But notice 0 equals 0. So since the result is 0, 3 checks out. Okay. Since the result is 0, 3 checks out. And excuse me, I did not realize that. I did that all the way up there. So pardon me. Okay. Now we can check 4, but we don't need to. But this is how you check. You only need to check one solution in this problem. Okay. And so again, when you're dealing with this, we need to find a multiple of 12. So list the multiples of 12, and then whatever multiples of 12 you want to make sure that it adds up to be negative 7. Okay. Example number 2. Example number 2 says solve 2 times x minus 3 squared minus 18 equals 0, and then give exact solutions. Okay, so this equation already has a squared expression. So the square root method is more efficient. So first we need to isolate the squared expression. Okay, so we have 2 parentheses x minus 3 squared minus 18 equals 0. From there, we need to move the 18 over, add 18 to both sides. This leaves me with 2 parentheses x minus 3 squared equals 18. Then from there, we want to divide 2 to both sides. Dividing 2 to both sides, we have x minus 3 squared equals 9. Okay. Now we need to take the square root of both sides. Take the square root of both sides, or this side and that side, to get rid of the power of 2. So I'm going to do that up here. Taking the square root of both sides. Draw an arrow so you'll know. Taking the square root of both sides, we end up getting rid of the power of 2. So we have x minus 3 equals plus or minus 9. Or excuse me, plus or minus 3. Plus or minus 3. Okay. Now we need to solve both equations. Okay. Because this is 2 equations. We have x minus 3 equals positive 3. X minus 3 equals negative 3. So let's go ahead and solve. So we have x minus 3 equals 3. And then we also have x minus 3 equals negative 3. Adding 3 over here, we have x is equal to 0. Adding 3 here, we have x is equal to 6. Okay. So we have the solutions. X is equal to 0. X is equal to 0. X is equal to 6. Okay. So now that we have our solutions, the plus or minus, again, the plus or minus symbol matters because both 3 and negative 3 square to 9. Okay. So the reason the plus or minus sign is there is because if you took 3 squared, you would get 9. If you took negative 3 and squared it, you would also get positive 9. So that's why it's important to know what the plus or minus means. Okay. Now let me move my keyboard here. Okay. Now you pause the video and try this here. Okay, so it says solve x squared plus 4x minus 21 equals 0. Then identify which method you use and why. So in this problem, this particular quadratic factors easily. So all we need to do is find 2 numbers that multiply to negative 21 and add to 4. And you might be already thinking of those numbers. Those numbers are 7 and 7 times negative 3. Okay, because that'll give me 21, and then that'll also give me 7 plus a negative 3 will give me the positive 4 that I need. Okay, so that's how those check out. So we have x squared plus 4x minus 21 equals 0. We know that it's going to be x plus 7, x minus 3 equals 0. Now we need to solve using the zero product property, which is setting this equal to 0, setting that equal to 0. So x plus 7 equals 0, and x minus 3 equals 0. Add 3, subtract 7. Doing this, you end up with x equals negative 7, and x equals positive 3. Oh, okay, you pretty much get it. All right, so the solutions are x is equal to negative 7 and then x is equal to 3. So the best method here is factoring because the trinomial factors very cleanly. Okay, all right, let's continue. Let's look at example number 3. Example number 3 states that we need to solve 3x squared minus 5x minus 2 equals 0. Use the quadratic formula. Show a, b, c, and simplify. Okay, so this equation is in standard form. Notice ax squared plus bx plus c. That's the quadratic formula. Remember, ax squared plus bx plus c equals 0. And just for reference, the quadratic formula is here, okay? All right, so solve 3x squared minus 5x minus 2. So we need to identify those parts, okay? So first of all, a is equal to 3, b is equal to -5, and c is equal to -2, okay? Now we need to write the quadratic formula, okay? The quadratic formula is the formula that I'm going to use here. So this can simplify to this, okay? So for example, x equals -b plus or minus b squared minus 4ac divided by 2a, okay? I'm just going to plug in that data that we have. We have everything that we need. So this will end up being, so we have b, it's a negative, so it's going to be negative -5 plus or minus square root of -5 squared minus 4 times a, which is 3, and then times c, which is -2. Okay. Then we're going to divide that by 2 times a. 2 times a is going to be 2 times. Okay. Now we need to simplify. In simplifying, we're going to end up with, let's see, 5 plus or minus, because these two become negative, or become positive, excuse me. Then the square root of -5 squared is going to be 25, and plus 24 divided by 6. Computing further, we're going to end up with 5 plus or minus, this is going to be 49. 49 squared is 7 divided by 6. Okay, so now we have two split solutions, right? One where we're going to do 5 plus 7 divided by 6, and then we have 5 minus 7 divided by 6. Okay, so we'll do 5 plus 7 divided by 6. That's going to be 12 divided by 6, which is 2. So x equals 2, right? Then the other, we're going to do 5 minus 7 divided by 6. It's going to be -2 over 6. X is going to be equal to -1/3. Okay. And that concludes this problem. Okay. So when you're solving a quadratic formula that's already in this form here, you can use, or excuse me, it says use the quadratic formula for any equation that is in this form. So when the equation is in this form here, you can use when the equation is set up like this, you can use the quadratic formula, which is this, to compute this particular problem. Okay. So again, the quadratic formula is right here. Okay. All right, let's continue. All right, example number 4. It says use the discriminant. So without solving completely, determine the number and type of real solutions for 2x squared plus 4x plus 7 equals 0. Okay, so we only need the discriminant. The discriminant is b squared minus 4ac. Okay, and so again, this is it's called the discriminant. Okay, so we need to identify. So we're using this equation here. We need to identify a, which is going to be 2, b, which is going to be 4, and c, 7. Okay, so we got all the parts that we need. So we're going to take b squared minus 4ac. B squared is going to be 4 squared minus 4 times 2 times 7. When we compute this, we're going to end up with 16 minus 56, which is going to equal negative 40. Okay. So the discriminant is negative, right? We see the discriminant is negative. So when the discriminant is negative, the equation has no real solutions. Okay. Very important. Okay. So negative 40 is the discriminant, has no real solutions. Okay. And type of, and the type is two complex solutions. Okay. Because obviously, um, this would have situationally two complex solutions. Okay. All right. Let's continue. A common mistake. Okay. Do not drop the plus or minus symbol. So a student solves this expression here and writes x minus 5 equals 4 only. Correct the solution. So the mistake is that the student only uses the positive square root, but both 4 and negative 4 squared to 16. Okay. So we must write plus or minus because x minus 5 squared equaling 16. Take the square root of x minus 5 squared and the square root of 16. You're going to end up with x 5 equals plus or minus 4. So again, you're going to end up having x minus 5 equals 4, x minus 5 equaling negative 4. Okay, so you got to be real careful because over here you're going to end up with x equals 9 and you're going to have x equals 1. Okay, very, very important. Okay, so whenever we take the square root of both sides of an equation, we must always use this right here. Okay, very, very important. Okay, let's continue. Matter of fact, I believe that concludes this. So just a final review, going back to the key lesson. Okay, factoring works when the quadratic factors easily. Square root methods work when a squared expression is isolated. Okay, just like the one we just did at the end. Quadratic formula works for any quadratic equation. This is the quadratic equation. This is the quadratic formula. So they go hand in hand. Formula, or excuse me, I keep saying formula. I probably said that during this video. This is the equation, and the equation tends to the formula. Okay, so anytime it's written like this, quadratic formula to okay, and then the discriminant. The discriminant tells the number and the type of real solution. Okay, and just for the record, if the discriminant is positive, there are two real solutions. Okay, so if it's positive, two real solutions. If it's negative, um, if the discriminant is negative, then no real solutions. And it has two complex solutions. Okay, very important. And then lastly, because you can have positive, negative, or you can have a also a discriminant of 0. So if it happens to be 0, then there is one real solution. Okay, one real. Okay, probably put. Okay, all right. And again, that concludes this video. Thank you for watching.